All right. Welcome, everybody. This is going to be a meetup that is going to be covering some really cool stuff with Corey. Welcome back, Corey, and also welcome for the for your first meetup, me too. So we're going to give folks a couple minutes just to hop on in. Got about 13, and we had 65, so I would say we want to get maybe a little bit closer to at least half that number. We don't have to quite get it. So feel free to, if you are, I'll mention this again once we get started, but while people are filtering in, if you want to talk in live chat, feel free to just say a quick hello, and we'll and also that way you can just test out doing a quick post, or get ready for your questions later on. So where is everybody tuning in from? You can do that as an initial poll. Let's see if we can get. We got XD Prophet saying hi. We got Kunalji saying hello. Corey, of course, says hello to everybody. Hello. Where's everybody tuning in from? If let's see. Oh, there we go. A-Team Trino, San Diego checking in. Subo Broto. I totally messed that up for sure. We got some folks from New York. We got Raj Satya from the Bay Area. Corey from Quebec. Did I say that right? Quebec. Hey, Elon. What's going on, man? From LA. Elon is one of our contributors that maintains the Pinot connector. Suvo. All right, I'll go with Suvo then. All right, we got.
So a lot of people from New York. Wow.
Yeah. Oh yeah. I mean, let me see. Oh, we got Rob from Boulder. Hey, Rob. Yeah, Rob is another one of our Trino super fans with Resurface. He was on the Trino community broadcast a little while back. It's like now it's like 5 or 6 episodes ago now. Hey, Tom from Sydney, down under. I totally botched that one for sure. I love me some Aussies. And hello, Bruce from Delaware. Let's see, and Nitu, you're tuning in from Toronto. We got a couple Canadians repping. Awesome. Wait, where is I? Here's what I was missing too. Hey, XD Prophet is using Pinot connector, so there you go. You can thank Elon. All right, I think we got a pretty decent quorum now, and everybody's chitting and chatting. So why don't we just go ahead and get started without any further ado. I think we're about. Let me see. Yeah, let's go ahead and get started. Great. So welcome everybody to this presentation. We're going to be talking about Trino, the Swiss Army knife for the analytics platform. This actually came out from a bit of a discussion that Corey and I had. I don't know. I'm trying to remember if it was like right after one of the community broadcasts. If you've never been on a community broadcast with me, like what we typically do is as soon as we go off the air, we end up having like another hour-long conversation that we should probably start recording. But anyways, Corey and I were just talking about like all these cool ways that him and his team at BlueCat are using the Trino for just kind of oddball type things that you wouldn't really expect. Like it's not the primary use case of Trino. And so really kind of excited to hear about a couple of these more at length. I vaguely remember a couple of them now. I think, some of them kind of do ETL-ish things, but I won't try to spoil too much of it. But they go a little further into, just a lot of really interesting ways that you can use it that, sometimes people even just approach with using ETL or using a manual task or some sort of, a scheduler or something like that. Like you can just end up using it for Trino. So we'll find out about a lot of these use cases that Corey will enumerate here in short. But and he's also going to kind of go over even maybe some of the more typical use cases as well. So let's go through a quick bit of the agenda. I'm going to cover a couple bits about the community stuff first and foremost, and then Neetu is going to come in for those of you who are kind of new to the community, who are still kind of figuring out what Trino is all about, and where we kind of differ from other like big data technologies or maybe even database technologies. If you're like if you're just new to databases all in general and you just heard about Trino, because I just blab about it all the time in database channels. If you're here and you're just trying to get a feel for it, she's also going to cover a little bit of that. Just the kind of primary use cases that we use for Trino. And then we're going to talk about the enterprise version of Trino, is the company that's built by the company that I work for and Neetu also works for. And their name is Starburst. And she'll cover a little bit more specifics about, what gets built on top of that and what advantages that Starburst actually brings to you. And so finally, then we're going to get to Corey's talk, the Swiss Army Trino, the Swiss Army knife for the analytics platform. He's then going to go over a couple of their common use cases at BlueCat and how they typically use Trino. It's probably how most everybody uses Trino, data lake and all these other kind of pieces that we commonly see. But then he's going to go into the meat and potatoes of the actual talk, which is going to be the uncommon use cases that we are not always expecting to see. So quick tidbits on the community. If you want to join one of the biggest pulse locations of where things happen for a lot of pieces in the community in terms of contributing, from asking how to get help and just figuring out what's going on, who's available and that kind of thing, definitely I recommend you join our Slack channel. So that's trino.io/Slack. .html, and there's a couple different channels in there. It's super useful to basically just be there and ask around. If you're totally new to the community, we don't bite. We typically like to give you a couple of resources to chew on in the beginning, and then definitely encourage you to ask all the questions you need to get yourself started and bootstrapped. And then there's this other show that I do along with my partner in crime, Manfred Moser. We co-host this podcast / we call it broadcast because it also goes to a whole bunch of video locations like Twitch and YouTube and LinkedIn. So we stream it and then we also make it into a podcast. And so this Trino community broadcast is like a bi-weekly show that we do where we just talk about all sorts of things going on in the Trino world. It could be anything as specific to Trino, like a connector or something. It might also talk about, we had an episode dedicated to our Trinoobies. That's my little term for anybody who is brand new to the Trino community. We also had another one that was like talking about bigger ecosystem pieces of like, bringing in, I think this is also with Corey actually, bringing like, ingestion and like, using bits like Kafka and Pulsar and how you get the data there in the first place before you're reading it out of Trino. So we talk a little bit of everything that's kind of like in Trino and then like, in the periphery of Trino. So definitely check that out. We also have these virtual meetups as you are here in the Trino Americas virtual meetups. But if you have friends and or you yourself are not actually living in the Americas and you want one that's going to be in a better time zone, we will slowly be rolling out more of these meetups to the EMEA and APAC regions as time goes on. It's going to be a slow build where we got to kind of crawl before we can run, but there's definitely going to be a lot more going on in the meetups there. Finally, if you want to contribute back to the community, I highly recommend going to trino.io/development. That's, obviously after you've gone and joined our Slack and asked us some questions on how to get started. But this is kind of the section where if you actually want to start like getting into contributing documentation or particularly code, then this is the kind of area where you can learn about our philosophy around open source, learn the actual steps to coding, and then actually get yourself up and running. And again, that along with the Slack resource is definitely the ways to go if you want to be a part of our open source community. Finally, we have the blogs page that you want to check out. There's also a whole bunch of stuff you can learn there. But likewise, you can also learn how to, what kind of things that we like to write about. So if you do want to contribute a blog, you can always reach out to me. I'm always on Slack, always kind of paying attention unless I am actually doing those, 6 hours or so of sleep that I get. But reach out to me anytime there. I will respond pretty quickly usually. And if you have any ideas for a blog, I'd love to just talk to you about that. And then for the docs, that last little long link there, Anna's going to be, by the way, posting these links in the chat. So don't feel like you need to write these down frantically. So you can click on this doc GitHub thing, and this actually has instructions on how you can also contribute docs. And finally, to the left here, this whole thing I've been ignoring for the whole time I've been on this slide is we have Trino Summit coming up October 21st. So that's coming up in a couple months. The date has changed around. If you heard me, I think the initial time I talked about this was supposed to be September 15th, and then this got bumped around due to the fact that this is currently planned to be a hybrid event that we're going to be hosting in California. Now, we are currently monitoring this very well could become a virtual event. Just it heads up for anybody who's already signed up live. We may be considering moving this to a virtual event due to the growing concerns with COVID and Delta variant. So do keep your ears peeled. We will be announcing that soon if we do have to end up changing this to an all virtual event. But it will be on October 21st. We will not be shifting the date on you anymore. And especially if it goes virtual, because now we don't have a venue that we have to actually get people physically fit into. But for the time being, that is the case. And we will be trying to continue the hybrid change that we made a while back and get everybody together and meeting face to face. But we'll see that and monitor that as time goes. For attending this meetup, you do have the opportunity to get some swag. So this is not in the meetup, the link that was just sent out to you. There's going to be a separate link that gets sent out here. So definitely pay attention to that. If you want to get a Trino shirt, please do sign up for this. Little disclaimer there. We are limited to the number of specific countries that we are able to send to. So if you are not in a particular country that we can send it to, then we will send you a gift card. Really apologize on that, but we will be trying to grow that out here in a short while. And finally, last little bit that you have to hear me talk about is questions. So easiest way while we're here during meetups to ask is ask us directly on YouTube chat like you all did whenever you were letting us know where you were living or where you're tuning in from. And then if you want to continue the chat afterwards, please do join Slack, and just easiest way is just to go on the general channel and start asking questions there. Or if you want to, find us on Twitter, always just do that. Tweet us at TrinoDB. Do follow us if you want to take the time to do that. And, I am also, I don't have this up here, but, I think it's on my little name tag somewhere down here. I am at Bits on Data Dev. So if you want to ask me any questions after the show as well, please feel free to reach out to me on Twitter. I am pretty frequently there as well. So with that, Neetu, would you like to take us down? What is this whole Trino thing? What are we here for? What are we talking about? And give us a little bit of background on Trino and how awesome it is.
Absolutely. Hello, everybody. Thank you so much, Brian. My name is Neetu Goswami. I'm a regional sales manager at Starburst. And prior to Starburst, I spent about 2.5 years at Databricks, helping customers with their data journey, their data initiatives. And now I've been with Starburst for about 2 months. So super excited to be here, to be a part of this Trino community. And, hopefully we continue on, embracing this community and, helping this community. So today I will be spending a couple minutes on just, what is Trino? For anyone that's joining for the first time, my attempt will be to give you a good idea on what Trino is and what are different organizations using Trino for. And also I'd like to introduce you to Starburst, which is the enterprise edition of Trino, okay? So just a little bit about Trino. Trino, which is formerly known as Presto SQL, it's an open source distributed SQL query engine created by Martin Traverso, Dane Sundstrom, and David Phillips. So in 2012, Dane, David, and Martin joined the Facebook data infrastructure team. Together with Eric Huang, they created Presto. And this was created to address the problems of low latency interactive analytics over Facebook's massive, you can imagine like Facebook with an army of data engineers and data scientists, their massive Hadoop data warehouse, okay? Trino is a distributed SQL query engine that allows you to perform fast SQL queries on large data sets. We're talking about terabytes, petabytes, exabytes, and it was created to empower analytics anywhere, right? So to be able to do analytics on any analytical database, whether it's on-prem, in the cloud, hybrid, multi-cloud, and with proven scalability and high concurrency, users can actually combine or federate data sources. Like I'm just throwing in some famous names, but BigQuery, Elasticsearch, MongoDB, Cassandra, essentially separating compute and storage functionalities, right? So that's one of the very prominent use cases for Trino, where you want to be able to separate the storage from compute. And with Trino, you can get compute capabilities pretty much on any storage, okay? But the ability to quickly and easily extract insights from large amounts of data is increasingly important to technology-enabled organizations. We call them disruptors, enabled organizations that are using data and monetizing data. But as it becomes cheaper to collect and store vast amounts of data, it is becoming very important that tools to query this data become faster, easier to use, and more flexible. The more conversations I'm having with customers on their data journey every day, I think data access has become such a prominent problem. And using a popular query language like SQL can make data analytics accessible to more people within an organization. So I've been part of other groups in the past, of the meetup groups like Spark and so on and so forth. And that was always a problem, where SQL is the prominent language that organizations are using to get analytics out of their databases for internal analytics. But it is becoming more and more apparent that if we can use SQL to get analytics out of the different databases, that's a huge success. So Trino essentially is designed to be adaptive, flexible, and extensible. It supports a wide variety of use cases with diverse characteristics, but these can range from user-facing reporting applications with sub-second latency requirements to multi-hour ETL jobs that aggregate or join terabytes of data. It provides an ANSI SQL interface to query data stored in Hadoop environments, open source and proprietary RDBMS, NoSQL systems, and stream processing systems such as Kafka or Kinesis, okay? Trino is allowing organizations like AWS, Netflix, LinkedIn to deploy a single SQL system to deal with multiple common analytic use cases and easily query multiple storage systems while also scaling up to 1,000 nodes. So that's been huge for Trino and Trino customers. The architecture and design have found a niche within the crowded SQL on big data space. Adoption in the big data space is growing quickly, and of course, meetups like us are, open source meetups like us, and community is continuing to remain engaged with our customers, with Trino users. But just a little bit about Starburst. As great as Presto is, and we all know how great Presto is, there was a big opportunity to build upon open source Presto to create an enterprise-grade Presto, okay? Our founding team has been involved in Presto since the beginning. In fact, the creation of Starburst started at Teradata, where our founders were already working on Presto, contributing significant time and engineering hours as the number 2 committers behind the Presto creators. The Presto creators are, in fact, now part of our founding team. 3 of them are actually part of Starburst, and 3 come from Teradata. But Starburst was created on top of Trino. So Trino is still, core part of the technology to give you enterprise-grade performance, Connectivity, we have over 50 plus enterprise connectors. Security, so we have Ranger out of the box. Management and support, which is 24/7 for your company's growing needs. With Starburst, the enterprise-grade edition of Trino, you can have a single point of access. So there's a paradigm shift that's happening. And as I'm talking to more and more customers, everybody's kind of wondering whether we should go for a single source of truth or single point of access. So we're kind of engaging in more and more of that data mesh conversations. So essentially, you can have a single point of access to all of your data, no matter where it lives, without needing to copy and move it. So that is substantially helping organizations reduce, ETL pipelines, reduce movement of data, and accelerating their data initiatives, their innovation, whatever they want to do with the data. But we are the analytics engine for data mesh, a decentralized, distributed approach to enterprise data management. Good part is Starburst can be deployed anywhere. Like I mentioned, it can be deployed, on-prem, in the cloud, whether it's AWS, Azure, or GCP. Hybrid, so if you have some data in on-prem, some data in the cloud, multi-cloud. So if you're leveraging all the three clouds, you can do that as well. And essentially, you can manage Starburst with insights. Data teams can now holistically view their clusters operation and query execution. So you get all that visibility with insights, so they can reach meaningful business decisions faster. All this with the support of the largest team of Trino experts in the world, delivering fully tested, stable releases and available to support you 24/7. All right. So with that, I just want to quickly show you how we really fit into the architecture. So how we think of ourselves and our customers describe is us as a consumption layer, semantic layer, abstraction layer, or data mesh, right? So that word is gaining a lot of momentum. Like I mentioned, we are the analytics engine, and we sit between any end user accessing data through tools like Jupyter Notebooks, Tableau, Power BI, SQL, or any of the tools that you see on top. On the left, data science tools; on the right, BI tools, and the underlying data sources or sources, and we do that across any deployment or hybrid deployments. So with that, thank you so much for giving me the opportunity to introduce Trino as well as Starburst. I'll be passing it on to Corey for some of the Trino use cases. But before that, any questions, please feel free to put that in the chat. Thank you.
Great. All righty, let me just press present. And we should be good to go. All right, so Trino, the Swiss Army knife for the analytics platform. Let's just get into this. So obviously, my name is Corey Darby. I'm a principal software developer at BlueCat. On a high level, all BlueCat does is we provide DDI. Well, not all we do. One of the things we do is provide DDI, so DNS, DHCP, and IPAM, really in that network space. And we work with enterprise company, and we're obviously using Trino. So just give you a little context of what BlueCat system looks like, just so you can get an idea of where we're using Trino, what we kind of look like. So we have an ingestion pipeline. It ends up in S3. We're using Flink to read in from S3. And then we're pushing our data to Pulsar, which is, if you're familiar with Kafka, very similar kind of concept there. And then we have another Flink job that eventually does our transformation and syncs all our data to S3. And then we go into the land of Trino with the Hive or Iceberg connector that we're using within Trino. And right now, we're mostly generating reports from that data. So Trino will run out SQL, generate these reports, and then we will serve out the reports to the customers and whatever they need, CSV, PDF, HTML, etc. So I want to jump into some of the common use cases that we have. So obviously, as I said, we're generating reports. So we are selecting data in our Iceberg and Hive connector in Trino, and we're doing normal SQL, and we return the results, and we have a report. So most of you, if you are familiar with Trino, this is like a no-brainer. This is what a lot of you are doing. There's nothing special here, right? Like you're selecting out data from your data sources, and you're returning the results somewhere else. Now, this is progressively going to get less and less common as we go. So things that we're using it for, or could use it for, is like observability platform. So let's say you have a team that deals with all your metrics in your company, and you're treating them like a black box, which is probably ideal because it's a different team. That team is able to hide the data sources, because think of what Trino is providing you, right? The observability platform could be InfluxDB, Elasticsearch, Prometheus. It could have S3 logs for application logs being written into it. And for us, we can use Grafana with Trino connector and Grafana, and then we only have to write SQL. So even though I'm using, as a dev, this observability platform, I don't want to write InfluxQL and then Prometheus QL and then Elasticsearch queries, and then I have to include S3 into Grafana and do the Grafana table plugin to show out the logs. No, I just write SQL. I got to use Trino, right? It's a single point of access for all my connectors. Like, these are the common use cases that we kind of see. So that's something we're obviously using it for. But something that starts to get more uncommon, that I don't see a lot of people probably discuss, but it's quite simple, is I've used it for our cloud bills. Because when you think about it, so BlueCat has like hundreds of AWS accounts, and we use something called Cloud Health, which is another service, and it just aggregates all of our cloud providers to one central spot. So Azure, GCP, AWS, and they provide a service to have one pane into our bills. But it's all UI, and it doesn't have the standard SQL flexibility that I want in reporting. So what do? Well, I wrote a script to export all the data into S3. And once all of our billing data from Cloud Health is in S3, I'm able to use the Trino's Hive connector. And the nice thing with this is, because Trino is like that single point of access, we could also tie into something like, oh, I have something like Prometheus behind that. So I can get the application metrics and the billing data now. So I can see if our bills are, oh, there's a spike in our bill for EC2 instances. Does that correspond to increase in our ingestion? Oh, that's right in Prometheus. I just joined the data. So I see what our ingestion rate was, what was our billing, how many EC2 instances did we have running? And right away I can see, okay, is the bill corresponding to just our system scaling up? Or did we introduce a bug, or did someone accidentally leave something running, or did someone deploy a pipeline that scaled out things it shouldn't have had, or did someone, like, there's always something. Like, it's one thing to say like, oh, your AWS bills are low. It's another to know exactly like, oh, my scaling groups are matching exactly my usage. And I can see that because here's my bills per hour. And then using Trino, I can also see the application usage, as well as like CloudWatch and the ingestion stuff through Prometheus. We have the stats in there. So it's really like this, a single point of access for all your data sources. And like, this doesn't sound some crazy complex, like, oh my God, this is like mind-blowing or groundbreaking. But for me, I was like, oh, I'm gonna have to pull this out in Python, and then I'm gonna have to write something to iterate over all this stuff and do everything in Python. And then I'm going to put in Excel, and then I'm going to go get the other stuff, put in Excel. But then I realized, wait, if I just write it to S3, I have Trino, and now I have SQL. And then I also have access to all the other connectors that Trino cluster is set up for. So, starting to get a little less common. I don't think they're complex scenarios, but a little bit less common. So let's get to even more less common. These are scenarios that Trino works very well for, but you might not be in that position to use it for this, just because you might have different stack, or you might not face these problems. But one of the things is data recovery. So as I mentioned, we run Pulsar. So just replace it with Kafka if you're unfamiliar with Pulsar. And let's say your cluster got nuked. Now, how do you replay the data? Well, for us, because we have the data in S3, we can figure out where we were. So I can read all the data from S3, and then just for BlueCat, we have to do some manipulation because the sync data is a little bit different than our data that's ingested it. But we do some transformation stuff, and then we're able to insert it back into S3, just in Trino with insert into from select all blah, blah. And basically this works because Trino has selected our S3 that has been synced. And then we basically insert it into our start of where our S3 files come from. And then our normal process takes over. So our normal ingestion at BlueCat wouldn't know that this is actually coming from Trino. It would just see these S3 files as, oh, this is new data. So the Flink pipeline would take over. It would read the S3 files, it would insert back into Pulsar, and we just restored all our data back into Pulsar, just like that. So very easy in a sense of doing it on Trino's side, but not a lot of people are thinking about, oh, my disaster recovery strategy for X is I just use Trino. I just select the data that I need, and you have to make sure that your connector obviously supports the inserts and things like this, or you could write it, contribute to the open source community, and then you just insert the data back at the start of your pipeline, and then everything just takes over. So this was something that was very, I'd say less common for most people, but I think it's just a really good spot where you can use Trino for its non-intended use case directly. It's not used for disaster recovery, but it is used for selecting data, inserting, if you turn that on. And for S3, that just works for us. So then we get into more disaster recovery, which is, so in Kafka World or Pulsar, let's say you didn't lose your data, but you lost the position of where your Flink job might be or your Spark job in your stream, right? Let's say it's 10 messages. It was at message 5, but you lost the Flink state and now it doesn't know where it was. Well, for our system, we're able to just use Trino to say, what was the last data that was synced? And what is the current data in the ingestion S3? Or actually in this case, because we are using the Pulsar connector, we're able to look right in Pulsar. So what data do you have in Pulsar? And what data was actually synced? And then from there, I know, oh, if there's data missing on the sync side, it couldn't have gone further than that on the Pulsar side. So it looks like this. Select the data from the Pulsar ingestion topic. So we know where we are, how much data is in the Pulsar topic, what's the data we have. Then we join against the data that's actually in S3 that we synced. So that tells us where are we in that reading of the Pulsar. If we're at message 5, message 6 is not going to be in S3 because a Flink job would have read message 6. So it would have been synced to S3. So then we know where our cursor position for the Flink job was in Pulsar. So then we're able to have the last known message. And then we're able to use Pulsar's management API to basically say, oh, this Flink job is actually at message 5. And we would be able to do that. Because if not, how would you do this? Most people would go, I don't know where the job was. So what we're going to do is we're either going to say it's at the earliest or the latest message. And if you go the earliest, you're going to duplicate messages, right? Message 1, 2, 3, 4, 5 have already been read. So you could have duplication, which is an issue if you have deduplication, but not everyone has that. And if you go to the tail end, you've actually lost data. Your Flink job, in this case, or Spark job, would have read message 6, 7, or 8, or 9, or 10. But we actually know where we are, because in the case of our system at BlueCat, I would have saw the data synced. So message 5 was the last message that was synced. I know that the position that the Flink job was at was message 5. So I can just update the cursor, message 5. So we had DR on restoring our Flink jobs using with Pulsar. So then we get into things that are less common because not a lot of communities necessarily using the Iceberg connector, but Iceberg is similar to the Hive connector in some sense. Like you're able to access S3 data. The way that you access that data and the way that the structured data is stored is very different. That's like a whole other talk. I think Ryan Blue did a Trino meetup with Brian. You should just Google Ryan Blue Trino Iceberg, watch the video. But one of the things that Iceberg does out of the box is it provides compaction. So you're able to have it run and compact small S3 files into larger S3 files. But how can we know that's actually working? Well, the nice thing with Trino is I can run the Iceberg compaction, and then I can actually ask Trino, okay, look at the data that was before the compaction, and look at the data after the compaction. And then you're just normal SQL. Is there any missing rows? No. Then I know that the compaction is actually row for row matching all the data is there. And that's the beauty of like mind blown. Yeah. So we're able to actually verify that the Iceberg compaction is working and not just bank on that the Iceberg community has said that compaction works flawless. We have the test. I don't want to bank on the test because if I go ahead and delete the prior data and keep the compaction and there is a row missing, I have data loss. I never want data loss. I want to actually confirm the data matches exactly. Row for row, everything is matched. All that has changed is simply the smaller files have been compacted into larger files. So yeah, we're able to produce the older snapshot. We're able to produce the older snapshots for Iceberg maintenance, and then we're just able to clean up the ones that we know have actually been successful. Another thing with Iceberg is when do you trigger compaction? And how do you know what to compact? Well, there are some hidden columns, as well as we internally have added some stuff that's not open source to expose all the Iceberg manifests and metadata. Maybe one day we will be able to contribute back to open source community, but we trigger this via Airflow because we need this to run on some sort of schedule. And basically what we're doing, and the asterisk is some of the stuff that I'm going to talk about is not open source. We've done the contributions on our side. We haven't contributed back yet. Is in Trino, I'm able to access the internal hidden columns of Iceberg, and that will tell me things like what the file size are for some of the data files, as well as a manifest list. What are all the data files within the manifest list? And then I'm able to go, okay, so I know all the files on S3 relate to Iceberg. And now I can look at the file size and go, okay, which ones should be compacted? And I don't have to write this random Python thing that's going to S3, list objects, getting out the file size, and then doing this. I can just use Trino. I can just use the Iceberg connector in Trino and have the hidden columns, and then just write standard SQL and just compute this. So yeah, it determines which files should be compacted. And then obviously, for those familiar with Iceberg, there's just an API that we call for maintenance on compaction, and we say compact this range and these files that we've determined from the SQL. Less common is, and more related to BlueCat, is we have static materialized views, is I guess what I would call them. So the reports I was talking about are just JSON files that we basically serve out to the front end. So they're 100% static, and then we are able to cache them on the front end. The reason why we do this is it's an easy approach when we added Trino and this whole new data platform, because if the platform went down, the front end user never knew. Because we compute out these, we create the JSON files, and we can put in like behind a CDN, as well as the browser can cache it. So if we have an outage, say our Trino cluster goes down or the Flink job stops, the user is unaware. Our entire backend could go down for the reports, and the user would be unaware, right? So because it's just this little middleware that goes out, gets the JSON file, and serves it back out to the front end, and the front end caches it. So the way this works is we basically just have Kubernetes cron job or Airflow. I should mention that Airflow is from Airbnb. It's a scheduler, but you can essentially just think of it as a fancy cron job with a bunch of UI and stuff like that. So we insert into S3 from all the data we're selecting. So we generate whatever our query is. We do the aggregation. Then we insert it back into S3 as the JSON files. And then we just have our little middleware that serves out the S3 files. And that's how we are able to have basically these static materialized views for the front end. And then, yeah, the front end is obviously able to take advantage and cache. So we get into less and less more common, which is when you start getting into things like combining your real-time streams and offline. So we're using Pulsar, and you might be in a scenario of, I want to look at data or I don't know, real-time visits, or let's say your advertising company for bidding. I can't just look at the sync data. I need to know what's happening as the stream is ingesting it, right? Because it might be like average price per 1,000, and you might have just had a huge spike. You don't want to just look at your data that's already gone through everything. I want to basically look at the stream plus the real time. And we're fortunate enough to use Pulsar with the connector. And for that, we just have S3 connector, the Pulsar connector, and all we're doing is joining. And then for us, we have to remove duplicates. because the stream doesn't necessarily always get flushed. So you might have data that's still in the stream, but also has been synced to S3. And the reason why is because the multiple subscribers on the stream could be at different points in time. So we remove the duplicates, and then we have our real-time stream plus our basically our sync data, our offline kind of stuff. So like I said, those were a little bit less common, but you could see how to get there depending on what your stack looked like. If you could use it for the DR if you're using Pulsar like us and whatnot, and using it for Iceberg, all those are applicable if you're using the Iceberg connector. Now, the things that we haven't fully used it, but have started tinkering around with, and we're kind of more interested in what the community thinks. And some of this might just sound a little crazy, so bear with me. We've thought about using it for REST APIs, like comparing AI models against each other. And how this would work is you would have like a user-defined function in Trino. You would select your data that you would want to input into, say, let's call it TensorFlow. And it would look, REST API called to TensorFlow, and it would look something like this, which is essentially you're going to use your data that's been synced somewhere or on your data connector, and you get your input, and you essentially would be able to call out to something like TensorFlow from Trino and say, hey, here's my input. I want you to call V1 on the model, comma, also I want you to make the same API call, but for V2 with my input. And the nice thing about this and why we've been tinkering around with this is I don't need to write Spark or Flink at all. I can go to my research team and say, all you're doing is interacting with Trino. You upload your new model, and if you want to go and get all the old data or the real-time data, because it's this single point of access, we have the real-time data, we have the sync data. You can compare the real-time versus the old-time, historical, whatever. You just write the SQL, but now you're able to quickly compare, like, okay, how did V1 look against V2? No Spark or Flink. You don't have to know about the streams. You don't have to do any of that. You don't have to write the job or have like a shadow topic where you have a different Flink job and you're basically reading from that, your primary topic, and then that job's just calling a different TensorFlow, or any sort of like shadow load balancer was another thing that we had thought about, which is for every time I call TensorFlow for V1, I call TensorFlow V2, all this special infrastructure. No. Sit down with my research team, data scientists, and just like, here you go. You're just in Trino. Select all your data, do all your aggregation, and then just V1 and V2. So this is something that we had thought about that I'm hopeful that maybe it sees the light of day, or that someone in the community also sees the value and makes the contribution. Like we have shown that it's doable on the user-defined function stuff, but we had other concerns, which is like, oh man, this is just going to spam our TensorFlow servers, and how would we go around batching things on the Trino side? So it is less like, we're at the extreme now. We're at the spots where it's like, imagine a Trino that could do this. So the same thing, triggering external calls. So this is just going a step further than the TensorFlow stuff, but just imagining the use case is you have something like Kubernetes or Airflow on some sort of schedule, and you have your user-defined function, you're selecting your data, you're doing your aggregation, and the unique thing here is, okay, so I just directly from Trino am able to call something like onDuty. And you could do this, obviously, you could just have your Python script, call it to Trino, and then call it to PagerDuty. But the thing is, like, you get into the problem of like, where's that live? And now, like, who's managing that and who's responsible for it? And also, like, I think there's some nice things on being able to have all these different connectors, because, like, what happens if it's like Trino calls out, gets the data, and then I call out to TensorFlow and I ask a model whether or not this looks like an incident, and then I call something like PagerDuty based off what the model says. And you could obviously do this in Python script, but like, I'm all about the single point of access Trino, and like, I just like it. So, and then once again, same thing, but for scaling is something we've looked at using Trino for, which is same kind of premise. So for us, we would select Pulsar internals data, And from there, we could determine if we're falling behind or not. And then we just basically make a REST API call for Flink. And then we're able to scale Flink based off of the metrics that Trino just gathered. And the reason why you could say, like, why just use Trino is because we've already set up all the access for Trino to have access to all these different data sources. If I run a Python script, wherever that Python script is running now also needs equal access. And now I need to introduce all the same auditing, right? So like, it might not just be that it asks Pulsar about subscriptions. It might also go to CloudWatch. It might also go to S3. And based off of like the delay from Pulsar, based off of our CPU on AWS, on CloudWatch, based off of how quickly we're syncing data, it might want to make an action now. If I do that all just on Python, it now needs access to CloudWatch and AWS. And for us, we have 100 AWS accounts. So either it has like payer access that can soon roll into each account, or it has access to all 100 accounts under some sort of role. Then on top of that, it needs access to Pulsar that runs in our Kubernetes cluster. And on top of that, it would need access to S3, which is the customer data. And that needs to have an auditing trail. So now I have to have this Python script actually call through another service that would actually go out and get the S3 data, like all of this complexity. Versus if I already have it in Trino, like it already has access and it already could have the auditing log in place, and everything is controlled through that one point of access. I thought this was funny, was like, imagine scaling Trino based off of Trino's queries on the Trino JMX connector. And I think that can mostly be summed up by this slide, which is, yo dog, I heard you like Trino. So we use Trino to query Trino, to scale Trino to use more Trino. That's it. So that is the end of my slides. And this is the Q&A portion, I guess. I thought maybe one of the other people would jump on. Oh, there we go.
Hi, can you hear me?
Yes, I can hear you.
Okay, awesome. Thank you, Corey. That was awesome. I hope everyone enjoyed it as much as I did. We had a question. I think Brian tried to answer in the chat, but maybe you want to go. I don't know if you can see the chat. If you want to go into more detail.
Was this just the one about the Trino cache results of a query?
Yep.
What was the reply there? Because like, I don't know, because this is directly just on the Trino stuff. So I assume so, but.
Here is the Trino has materialized views as an option depending on your use case. There's also some for caching and Hive.
Yeah, so we're basically doing the same thing as the Trino materialized views, but we're just going a step further and just writing out the JSON file. And the reason why is we're going to serve out that file to the front end no matter what. So there's not a reason for me to call Trino for the materialized view on the Trino side, then serve that back to the middleware, which is going to do transformation of JSON that go back out to the front end. The other thing is we hedge our bets. Like I said, this was a big sell in the company, and it was a new thing, and they're very antsy about downtime. So the easiest thing I could do there is I don't even call Trino for a materialized view. What I do is I just go basically to CDN and just serve out the JSON file directly. So Trino in our setup could entirely go down, and the customer is unaware that it went down, at least in this scenario. So.
Awesome, thank you. I don't see any other more questions at this time.
Rob is super excited for a +1 of triggering external webhooks. Yes.
Yeah. Yeah, don't forget to sign up for a Trino t-shirt. If no one else has any questions, I guess we can end a little bit early. Thank you so much, Corey and Nitu for
no problem.
Nitu for starting off. That was awesome. We'll be posting the recording on the meetup page, so this will be available for everybody. So thank you again.
And I think there are 2 more questions.
Oh, yeah.
Just as we're about to end.
Just as we're ending. Thank you. We have 2 more questions. Are you using HTTP headers for the caching at the CDN level and standard HTTP caching?
Honestly, I don't even remember because it wasn't me who implemented this section. I would assume so. Because like I said, they're literally actually just static JSON files. Like that's it. And we just replace like every time the Airflow in our case runs on like whatever time it's set, we compute the new results with Trino, and then we replace that file. And I'm pretty sure, I guess we would expire the cache at that point, and that's how, or the content length would change, so the cache would know. Yeah, so.
Awesome, thank you. We have another comment. So assume I'm integrating with an external customer that has this streaming data endpoint.
The excitement.
And then
The poor person's just like, hold on, hold on.
Shuvo.
I mean, while that's being written, I could say that the other thing with what I hadn't mentioned is the system that we have is different than most new systems in the sense that we have a lot of single tenants, and then on the Pulsar side, we merged to a multi-tenant environment. So this is also why some of the stuff that I was talking about, which is like having Trino as this central point of access, is also important because we're going from single tenant to multi-tenant. Now we need to track who's touching what.
Oh, here's the rest of the question.
So,
okay, here we go. Are there tutorials, write-ups, quick starts on this use case?
that I don't know. I would have to even know more. Like I don't fully follow the question. Like the question I got is like, are there tutorials right up there? Of course, but like the idea is to bridge the streaming data endpoint that's external to Trino via NATs. Okay. So assume I am entering with the external customer that has a streaming data endpoint. Don't know. Sorry. Send the question to Brian on Twitter. He'll answer.
Yes, definitely. Yeah, Brian Olson, he had to jump, but he would probably know the answer to that. So you can, any of those, the link I sent earlier, this link has all the resources in the Slack information if anyone wants to post more questions as well. Okay, awesome. All right, well, thank you again, Corey. Thank you, Neetu, and Brian for the intro. Here's the resources, and I hope everyone has a good rest of their night.
Thank you, everyone.